All right, guys, I'm just going to record myself real quick doing your study guide. That way you know what you're doing. So I'm going to click on the first one and make sure you write the work in that box so that tomorrow or whenever you're taking your test, you know what you're doing. All right, so I'll do the first one. It says subtract from this. So we're doing subtraction. All right, and remember, if I'm going to the cafeteria from my classroom, where do I start? My classroom, right? So I'm going to the cafeteria from my classroom. I start my classroom. So I start after from. So I start with this. So it's really negative 5x squared plus 5x. All right, minus, because it says subtract, 8x squared, or negative 8x squared, I'm sorry, minus 9. Okay, so that's the question. All right, so we're going to go ahead and ask, is there anybody outside the house? No, so there's nothing that needs to come in. So I'm just going to write this out again. So 5x squared plus 5x. Now, there is someone outside this house, so I'm going to go ahead and distribute it in. Remember, you distribute through multiplication. What is a negative times a negative? So if you forget, a negative and a negative, is that a happy or sad face? That is a happy face. That means that's positive. So this is positive 8x squared. All right, then I go ahead and distribute it because we're not rude. We say hi to everybody. Negative and a negative makes a positive. So that's positive 9. Okay, then we're going to go ahead and combine like terms. Okay, so I'm going to put a box around everything with a squared term. Don't forget the symbol. I'm going to put a box around everything with a squared term. Don't forget the symbol. All right, and then I'm going to go ahead and combine those. And again, you're just going to put this in a calculator. Negative meets positive. They're going to fight. Who's going to win? Positives win because they have more people by 3. So I've combined the box. Bring everything else down. So I'm bringing everything else down. So I've got a positive 5x here and a plus 9. Okay. Is there anything that looks the same? No, because x squared is by itself, 5x is by itself, and 9 is by itself. So nothing looks the same. There's nothing left to combine. This is my final answer. So I'm just going to go ahead and put that into my answer. So 3x squared plus 5x. So 3x. To get the squared, it's shift 6. Or you can press this keyboard right here and use the squared button right there. So 3x squared plus 5x plus 9. And you can use the keyboard here to type it in if you don't want to write it out. 5x plus 9. Okay. All right, so if you got that question wrong, again, or you don't understand my explanation, you can click right underneath the date, watch help video, and they'll do more than the one example that I just did. But I'm going to go on to the next problem. So I wrote my work in that first box, and I'm going on to 3-step linear equations. So once again, you copy your question down. All right, I'm doing a 3-step linear equation. First thing I do is going to draw a river. Right, I'm going to label boxes. Don't forget the symbol. Boxes with variables, and then I'm going to put circles with constants. Don't forget the symbol. Don't forget the symbol. All right, it doesn't matter which one you move, but I need boxes on one side, circles on the other side. So I'm gonna move my circle to the other side. So if I move -8 crosses the river, it gets wet, it's gonna change from -8 to what? +8. Okay. Then I'm going to take the box that's on this side, because now I got circles here and I got a box here, but this box shouldn't be over here. So I'm going to take this box and move it to this side. It crosses the river. It has to change. So it's positive 10x crosses the river. It's going to change to negative 10x. So now it's gone. Okay. So now I look. I have only circles on this side and only boxes on this side. So now I'm ready to combine. Again, you can just use a calculator. Okay. But I'm going to do positives are meeting negatives. What's going to happen? They're going to fight. Positives are going to win because they have more people. By how many? By 2. So that's going to be 2x. Again, put that in the calculator. 12 minus 10 equals positives are meeting positives. What's going to happen? They're going to join. So 8 plus 6 would give me 14. Okay. Then what's my final step? Because I remember I want to isolate x. Then I want to do the opposite of what it is. Right now it's multiplication. So I'm going to divide by 2. So now I get x equals, and again, you're going to put this on the calculator, but you should get 7. Okay, so x equals 7 is my final answer. So I come over here, x equals 7, submit. All right, I'm good to go. So once again, if you didn't understand that explanation, click on this watch help video and they have like 5 or 6 more examples. I'm going to go to the next problem. So I'm going to write that problem down so in case I forget it, I can use it on my test. So I click on the next problem and I repeat the process. So it looks like we're still solving equations. This time we have distribution. So anytime we're solving equations, you always have to draw my river, right? Always, always. All right, we do have a house here. Let's go ahead and get into the house. -5 says hello to the first person. We're not rude. So -5 times. All right, so we're going to go ahead and distribute. Oh, draw a river first, always. Go ahead and distribute in a negative, and its distribution is multiplication. All right, so negative times a negative is a positive. Again, you just do your face. That's going to be happy. That's a positive. So -5 times -5, -5 times -x is positive 5x. And then we're not rude, so please make sure you say hi to everybody inside the house. So -5 times -4. Negative times a negative, we just said is a positive. 5 times 4 is 20. Bring everything else down. So everything else stays exactly the same. All you did was distribute into the parentheses. Now that you've done that, I need to see boxes and circles. Okay, so boxes with my variables, don't forget your symbol, okay? And if there isn't a symbol there, you know that it's positive. All right, here's another variable. Don't forget the symbol. Is there another x? Nope, there's no other x, so that's that. All right, let's go ahead and find our numbers, our constants. Don't forget the symbol. So circle all our constants, don't forget the symbol. All right, the key is to get the boxes on one side and the circles on the other side. So since the box is already here, I'm just going to go ahead and move the circles onto this other side. Remember, when you cross the river, what's going to happen? You're going to change. So you're changing from -5 to +5. This is now changed. All right, I want to move this other circle. Crosses the river. It's going to change from +20 to -20. All right, then you're just going to put this in the calculator, okay? But we'll do it by hand. Positives are meeting negatives. They're going to fight, okay? So remember, multiplication is the face, and then adding and subtracting is the teams. So positives are meeting negatives. They're going to fight. Who's going to win this battle? Positives are going to win by how many? By 2. So it's going to be 2x equals. Then we're going to combine all of the circles. And again, you just put it in the calculator, but we're going to do it by hand. Positives meet positives, more positives. So there's 18 positives meet 20 negatives. What's going to happen? They're going to fight. Who's going to win? The 20, the negatives, because they have more people. So that's negative. And 18 people are still going to fight them. So they're going to have 2 left. And then final step, how do I isolate x? Well, the operation between 2 and x, is multiplication. So to undo multiplication, or when multiplication crosses the river, it becomes what? Division. So you just divide by 2. Okay, so you're going to get x is equal to, here I have a negative divided by positive. And again, you're just putting this in a calculator, okay? Negative divided by positive, that's going to be an unhappy face, which means it's going to be negative. 2 divided by 2 is 1. So this is my final answer. So x equals 1. So if I try to type in x equals 1, it tells me, oh, don't do that, just type in the number. Okay, cool. So I come back here and I just type in the number. Boom, and I got it wrong. Okay, so I see why I got it wrong. I said -1. Why did I put +1? That's my bad. I just mistyped it. So x is equal to -1. For some reason, I only put 1. So x is equal to -1. All right, go back to the next problem. Sorry. Oh, it's not going to mark it right because I already moved. So next one is single step literal equations. So again, copy the question down. And this we're solving for B. So actually, let me get the question in. All right, so we are solving for B. So first thing I'm going to do is draw a river. I want to isolate B, okay, get B by itself. So you really have to ask yourself, what is bothering B? And you can do this one of 2 ways, and I will do it both ways. No, actually, I'm just going to do it one way. Okay. With this one, you can get a lot of questions, but the main question is how do I isolate it? What's bothering the B? Okay. So right now, divide by 6 is bothering it. Well, divide by 6 goes to the other side. So the operation is divide. When it goes to the other side, it becomes what? Multiplication. So it becomes multiplication, that's gone away. So now I have 6t is equal to 5b. Okay. Again, what's bothering the b? What's between 5 and b is addition, subtraction, multiplication, or division. It's multiplication, it's a visible multiplication. So how do I get rid of multiplication? When it changes to the other side, it becomes what? Division. So b is equal to 6t over 5. I'm just going to do a few questions because this one's going to take you a few times. So I'm actually going to just hit show example. We're just going to do a whole bunch of examples. All right, so solve for capital B. This one is that. Solve for capital B. So find capital B. It's right here. All right, what's bothering it? All of this. And since it's parentheses, it's all together. What's the operation between this parenthesis and B? Multiplication. So the first question is, what is the operation? Once you know the operation, do the opposite. So that's the operation. So you're going to divide both sides by 3 plus g cubed. And what that's going to do is that's going to get rid of that, leaving just b. So b is equal to this part right here. And because the question says b is equals already, you want to make sure that you just put in the right-hand part. So 4t over 3 plus 3g. 4t over 3 plus 3g. G cubed, I'm sorry. All right, so again, let me do another example because it's just going to take you a few examples. I'll do one more, and then after that, you can watch whoever the Delta Math person is doing the examples. All right, so again, here I want to isolate b. So find what's bothering it. So right here, so I've got divide by 4. So how do I get rid of that? Multiply by 4, right? So if I multiply by 4, and it's multiply everything by 4 times 4. Okay, that's done. What will I have left here? I'll have 1 times b equals, and you can distribute it in or you can leave it outside. I'm going to be lazy and just leave it outside and see if it accepts it. All right, so there. I can now, the operation between 1 and b is multiplication. I can divide by 1, but since it's 1, that's just 1, right? It's an invisible 1, so this is really my answer. So let's see if they put it this way or whether they distributed it. They left it like that, so we can just be lazy. So again, if this one you're having problems with, just make sure that you click the watch help video and do it. So again, they've already got your B. I'm going to put in my original answer. Type it in. So it was 6 divided by 5t. That was my original answer. Where's t? I'll just type it in. Okay. Right. All right, so once again, just watch this video, as many questions as you need to understand it. Okay, guys, I'm going to go ahead and split my screen too. So you make your box small right there, these 2 double boxes on the top right-hand corner. All right, and then you can come to the edge and you can extend it however you want to. I'm going to make it half my screen. And then I'm going to take my calculator and put it on this other side too. So I can just also use the calculator as well. I'll make my calculator one, my Delta one a little bit smaller because the question is small, and I'll make this one a little bit bigger. So I'm going to make it like a third and 2/3 of my screen. That way I can see what I need to see. All right, so I'll click on the next question. Okay, so this is the question. It says solve the inequality and graph the solution on the line provided. So once again, I'm just going to copy the question down really quickly. So copy the question down. Okay, first thing you need to do is you're going to solve the equation. So we're still solving equations. This time it's just an inequality. You're going to draw a river. Okay, boxes and circles. So you're going to box the variables. Don't forget my what? My symbol. Is there any other variables? No, there isn't. So a box there. And then I'm going to circle my constants or my numbers. Don't forget the symbol. Don't forget the symbol. All right. Now, on this one, it does matter where the boxes and the circles are because of this inequality, because it's not an equal sign, okay? So boxes need to stay on the left for graphing purposes to make it easier. So we're going to go ahead and move circles to the right. So again, this crosses the river. It gets wet. It has to change clothes. So it has to change from -4 to +4. Okay. So now I have a box here, which is just -2x. On this side, I have greater than. On this side, I have 10 plus 4. And if I just put that in the calculator, in case I don't know, 10 plus 4 is 14. 10 plus 4. The calculator will tell you. So once again, you can just put it in the calculator. It's going to be 14. Okay, then I'm going to do the next step. Now, the only difference when you're solving equations and inequalities is you have to remember that if you multiply or divide by a negative, you have to flip the inequality. You have to remember that, okay? That's the only difference. So I'm going to go ahead and keep solving. So right now I'm going to divide. I'm trying to isolate x. I'm going to divide by -2. And immediately, because I'm dividing, I look, did I multiply or divide by a negative number? I did. So because I did, I have to do what? I have to flip the inequality. So this is going to change from greater than to less than. Okay, so again, if I multiply or divide by a negative number, flip the inequality. Okay. Now, if it wasn't by a negative number, if this is not negative on the bottom, okay, then I just leave it the same. So put this in, this crosses out, so I'm going to have x. Put this in a calculator, but again, I'm just going to do it by hand. I have a positive divided by a negative. What kind of face is that? It is sad, so it's going to be sad 7. Okay, so x is less than 7. So the reason I wanted you to keep the boxes on the left is so that you can graph it the way I'm going to do it. So you copy your inequality 2 times, the same one, whatever it is. You draw a line from the left and a line from the right. And then you ask yourself, which one of those 2 lines looks like an arrow? So does this look like an arrow, or does this? This one does, right? So this arrow is actually going to be going in this direction. The second question you ask yourself is this. Does that look like that, or does it have an equal sign on the bottom? If it has an equal sign on the bottom, it's a closed circle. If it doesn't have an equal sign on the bottom, it is an open circle. So even if it looks like this, if it has an equal sign on the bottom, closed, open if it doesn't. So in my question, does it have an equal sign? No. So this is just less than. This you read as less than or equal to. Okay, so just less than is open. So it's going to be open at -7. Open at -7, which is between -6 and -8. Open, and the arrow is going to the left. All right, so let me go ahead and put it all in here. So what's the inequality notation? It's right here. Oops. It's right here. X is less than, and you're going to write the whole thing. So you're going to write x is strictly less than -7. And then to graph it, you're going to do an open over here. So you're going to click. So it says click and drag to plot the line. So I'm going to click and drag. But that's a closed circle, right? So look at where it says click line to delete. So if I made a mistake, I can click that to delete it. What was my number? -7. So it's between here. Okay. Click closed circle to change it to open circle. So my circle was supposed to be what? Open. So I'm going to come here and change it to an open circle and then submit my answer. Yay. Okay. All right. Then I'm going to go over to the, all right. So I'm going to do the next one, which is determine if set of points is a function. So again, what makes a function is that x does not repeat. Okay. X does not repeat. Be careful, because you do have to read the question. Sometimes it's if it not a function. So what does this question say? Not a function. So I'm just going to find all the ones that are functions. So remember, x cannot repeat. So let's look at all my x values. Do any of these repeat? No. So this is a function. All right, let's look at my x values here. Do any of these repeat? Yes, right here, right? So this one and this one repeats. This one is not a function. So technically the question is which one is not a function. So B is the answer for my question, but I'm just going to keep going and showing you. So again, it is a function if x does not repeat. So you just keep looking at the x values. X value for each coordinate. Does x repeat anytime? It does not. So this is a function. Does x repeat? No, it does not. So this is a function. So it's not a function on B. Why? Because x repeats. You have a 2 here and a 2 here. Okay, so that one is my answer. All right, I'm going to go over to the next one. Determine if the graph is a function. So you're going to click on it. With a graph, okay, you just need to do a vertical line test, or you can write points down, but nobody has time to write points down. So we're just going to do a vertical line test. So to do a vertical line test, all you have to do is draw a straight line down. Does it go through the graph? And this is the graph. Ignore the coordinate plane. This part right here is the graph. Okay, so does at any point this green line go past this red line 2 times? Like, does it hit the red line 2 times? If I just do a vertical line everywhere, does it pass it more than 1 time? It does not. So this one is a function. All right, I am going to find an example which tells me it's not a function. So just hang tight real quick. I'll do another example. Next problem. Or it's not going to let me do another problem. Pause. Next problem. Oh, good. Okay, congratulations, whatever. All right, so next problem. So here's another problem. All right, and again, I'm just going to do the same thing. I'm going to do a vertical line. So I'll draw the original graph. This is the graph. It looks like this and like that. Okay, and I'm looking that every time I draw a vertical line, this is a vertical line, it does not cross that red line more than one time. If it crosses more than one time, it is not a function. So x is repeated at these 2 points, and I'll just prove that to you really quickly. I'm going to write down these 2 coordinates. So this coordinate right here is, okay, and again, my writing is going to be a little off, but -6, 8 is this one. And then this one right here is -6, -7. And you can see at that point, x is repeating. So that's what a vertical line test does. It makes it to where you don't have to write coordinates down. So if it crosses more than one time, it is not a function. So this one is not a function. If it only crosses one time, it is a function. I'm going to do another one of this because for some reason I didn't press enter. Let me just submit it. There we go. Okay. Oh, it's because it's supposed to do 3 questions. I got it. All right. I'm just going to do 3 questions actually and just be done. So is a function represents a function. So I need it x not to repeat. Let me do this again. All right. Looking at my x values. Does it repeat? Yes. So this is not a function. X values. Does it repeat? No, this is a function. X values. Does it repeat? Yes, right here. Not a function. X values again. Does it repeat? Yes, right here. So not a function. So the one that is a function is B. So be careful as to what the question's asking, because it can ask, is it a function? Is it not a function? So be careful. All right, perfect. All right, I'm going to go into visual, domain, and range. All right, so do remember that domain is your x-axis and range is your y-axis. All right, so determine the domain. I am going to answer both questions while I go over it instead of just the question I'm asked, because you can be asked for range or domain. So I'm going to do both just in case that's your question. So in my question, they're only asking for the domain, so I'll only put the domain. But here I'm going to work them both out. So remember, domain is which values? Your x values. So go to the end of the graph on the left, right here. And actually, I'm not going to put that there. What is the number? Because it's my x values, I have to go up to x, -3. So I'm going to do domain -3, and then go to the furthest point on the right-hand side. The furthest point of the graph on the right-hand side is right here. What's that x value? And it has to be x because it's domain is 5. Okay, then you have to deal with whether it is open or closed. So let's look at it. At the very end of the graph, is it open or is it closed? It's closed. So remember, closed is a closed bracket. Open is a parentheses. All right, so closed is a bracket. So this would be actually my answer. So I'm going to put it in here so I don't forget, and then I'll do range. So I come here and I look for, it's going to be close, close. So I look for close, close, this one right here. Then I just put in my numbers. So -3 and 5. But I'm going to go ahead and do the range as well. So that one is for domain. I'm going to go ahead and do range. So range, instead of it being x, my range is going to be my y value. So I don't care about this axis at all. I only care about my y. Okay. So for range, remember, it's from the bottom to the top. Okay, so let's do that. The bottom of the graph, the very bottom of the graph is right here. Okay, so you go to the y-axis from the bottom of the graph, you write the number down. You go to the top of the graph, So boom, 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 what is it doing? It's a line right here, right here. It's the top of the graph. You go to the y value there. Then you need to see, is it open? Is it blank there, or is it closed? So I can see, if you look, so I'm going to erase this real quick so you can see. If you look here at the top, it's closed. But even if this was open, right here it's closed, right? So it's closed because there's a blue line at that point. So it is closed. So remember, closed brackets, if it's open, it's parentheses, all right? And over here, it's also closed. So this would be my range. Now, if you have infinity, that's always open. Okay, but I'll do another question. Hopefully this one has two that I can do. Let's see, next problem. All right, now it's asking me for the range. So again, the same thing. The bottom of the graph, -9. The top of the graph, -4. So -9, comma, -4. And is it open or closed? Closed and closed. So this will be closed, closed. I do want to find one that is open, so hang on one second. It won't let me do another question, but maybe show example. Okay, here's one that's open, right? So this one, domain, will be left to right. So left of the graph, -4, right of the graph, 7. So -4, 7. And the left of the graph is open, and the right of the graph is open. So it's open, open. See, open, open, and then -7, -4, 7. Let me find another example. This one's open, open, -7, 8, domain. Find another example. Domain again, this one is closed, closed, -4, 8. Close, close, -4, 8. All right, do one more. This one's open, open, left to right because it's domain, right? -11, 10. Open, open. All right, range, I'll do this one more time. Bottom to top. The bottom of the graph is right here, -9. The top of the graph is not here, right? It's up here. Top is -1. And at this point, there is a blue line. So these dots aren't original in the graph, but the blue line goes through it. So it's closed, closed. Closed, closed. All right. So again, if you're having any difficulties with that, all you have to do is go to the bottom right here and watch help video. All right, so we'll take a look at appropriate domain for real world functions. Okay, and so for this one as well, if you don't understand it when I go over it, then again, right underneath here, you can watch the help video. But I'm going to go over it just to make sure you're okay. You might have to watch this a couple of times, but it's actually not as hard as you think. It's just it has word problems. I'm going to readjust my screen so we can see the whole question. I will need the calculator on this question, so I went ahead and readjust this. All right. A contractor is in charge of hiring people for a construction project. The number of days it would take to complete the project with X full-time workers can be found using this function. All right, so I'm going to take this function, I'm going to copy it, Control-C, and I'm going to paste it, Control-V. All right, it didn't quite copy it the way I wanted to do it, so I'm just going to type it in. So it's 315 divided by X. Okay. All right, so that's the function. Assume once workers are assigned to the project, no workers may be added or taken off the project until it's finished. Find and interpret the given function values and determine an appropriate domain for the function. So an appropriate domain actually comes from you answering these questions. And once you answer these questions, then you can find out the domain. And these definitions are listed on the board for you, but you do need to know what they are. So they'll be on the board when you come to class, but you do need to know what these each are. All right, so let's go ahead and work it out. So it says evaluate the function when f is equal to -3. Usually you see x in here, right? So wherever you see your x in your problem, you're going to put parentheses. And the reason I put parentheses is because it takes care of any negatives. So instead of x, I'm going to put what they give me, -3. But let's just say your function was a little bit more difficult than this. So let's say I had, I don't know, I'm going to make up a question just real quick just to make sure we're all okay. So let's do the 315. Then over here, let's say plus 2x, I don't know, minus 10. Let's say this is your function. I want to just show you that regardless of your function, the process is the same. Wherever you see x, you're going to put this parentheses. So I'm just going to copy that, Control-C, Control-V to paste. And here's another x, Control-V. Anywhere you see x, you're putting these parentheses. So if you see it only once, it's only one time. If you see it 2 times, it's 2 times. If it's 3 times, it's 3 times. And then this value here, f of x, so evaluate when x is equal to -3, that's what you're going to put in the parentheses. So -3 there. But if this was my question, I would have put -3 in each of the parentheses. Okay, so again, if you see it more than one time, you put it more than one time. but in my question, I only see it one time. So f of negative 3 is equal to what? It's equal to negative 105. Oops. Okay. All right. Negative f of negative 3 is equal to negative 105, meaning with, this is your x values, whatever full-time workers, the number of full-time workers, which is negative 3. And where do I get that from? I get it from the question. Hold on. Right here, it says X is full-time workers, okay? So they tell you X is full-time workers, and then the sentence right before that, the number of days it would take would be your Y values, or your equal, which is this negative 105. So meaning with negative 3 full-time workers, the project will complete in negative 105 days. Okay, so the answer is your Y value, and then what you're putting into the equation is your X. And this is what it means. Now you have to ask yourself, does this make sense? Okay, does it make sense that you can have negative 3 workers? Okay, so does it make sense or does it not make sense? Can you have negative 3 people? No. Can you have negative 105 days? No. So this does not make sense. All right, then you're just going to repeat that process for each of these numbers. So now I'm going to change this negative 3 to 7. Okay, so f of 7 is equal to what number? 45. Meaning, how many full-time workers? Which one is full-time? Which one of these numbers is full-time workers? If you forget, you go back to the question. X is full-time workers. So X is full-time workers, so that's 7. Meaning 7 full-time workers of the project will complete in how many days? The other number is the number of days. All right, does this one make sense? Okay, can you have 7 full-time workers? Yes, you can have 7 people. You can't have negative person, but you can have 7 people. Okay. Can you have positive 45 days? Yes, that's possible. 45 days. That's just a little bit over a month. So does that make sense? Yes, this makes sense. That means the domain exists here, but it does not exist here. All right, next one, 7.5. So now instead of 7, Control C, I'm going to paste it here, Control V. I have 7.5. So f of 7.5 is equal to 42. Meaning 7.5 workers. Now I can already say this. Can I have half a person? No. So I can already say this does not make sense. I cannot have half a person. All right, but if I could have half a person, 7.5 full-time workers, the project will be completed in this 42 days. And can I have 42 days? Yes, 42 days makes sense. It's not negative. So cool, 42 days. This interpretation does not make sense because I cannot have this 0.5 of a worker. So my domain does not exist when you have decimals. My domain does not exist when you have negatives, okay? So no negatives and no decimals. That's what you have to keep in mind when you come here. When you come here, now you have to know what these definitions are. So I'm going to write them down just for your reference right now, but I will display these, and since this is an open notebook, you should have them in your notebook. All right, but I am going to go over each one of them. All right, all real numbers is represented like this. It means every number that you can think of. That's negatives, positives, decimals, radicals, just anything you can possibly think of. Fractions, is even 0. Okay, so anything at all that you can possibly think of is included in all real numbers. That's what that means. All right, non-negative real numbers. Non-negative, I can write it out. Non-negative real numbers. Non-negative real numbers is every number you can think of that's not negative. Okay, every number that you can think of that's not negative. All right, the next one was real numbers. So real numbers in between a constraint. So inside some kind of constraint. Oh, sorry, I didn't mean to do that. All right, inside a constraint. What this means, it's between two numbers. So what they would do is they would give you 2 points. So for example, let's say from -3 to +3. They would give you a constraint. It's everything inside here. Everything, anything that you can think, but inside these 2 numbers. So can it be a number outside here? Can it be -3.5? No. But can it be -2.5? Yes. Can it be 0? Yes, because that's inside this section right here. Can it be 3.14? No, because that's outside. So anything that you can think of, a fraction. Can it be, let's see, what's a fraction in here? 1/2, absolutely. Okay, can it be a negative number? Yes. Can it be a decimal? Yes. Can it be 0? Yes. Any number that you can think of that's in here. Can it be a radical? Yes. Radical 2 is inside of here. Any number that you can think of that's inside here okay, will be a real number within that constraint. So that's what that means. Then after that, I believe it asks you for integers. All right, so let me go over integers. Actually, even before I do integers, integers is the next one, but it makes more sense if I flip integers and whole numbers. So I'm going to do whole numbers first. Whole numbers is anything positive that starts with 0 in counting numbers. What I mean by that is 0, 1, 2, 3, 4, 5. All right, so whole numbers is anything counting positive numbers, but it also includes 0. Okay, integers includes counting numbers, but it also has negatives. Okay, so no fractions, no decimals, same thing for here. No fractions, no decimals, counting numbers. All right, so integers you can have, let's say 0, -1, -2, -3, counting numbers, but you can have negatives as well as positives. Okay, so integers, negatives and positives, including 0. Whole numbers, 0 and positive numbers. Okay, no fractions, no decimals. And the same thing when they put that within a constraint. So it's the same thing as if it's whole numbers within a constraint or integers within a constraint, then you'll have those two constraints, but no decimals, no fractions, just counting numbers. Okay, so now that we've gone over what all of that is, let's look at our question one more time. So remember, I can have in this question, I can have, this one makes sense, a positive number, a whole number, positive whole numbers. Here, this does not make sense. I can't have negative numbers, right? That's what that says. I cannot have any negative numbers. So it's not going to be integers because that has negative numbers. It's not going to be all real numbers because that has negative numbers as well. And then the final thing is, can I have a decimal? No, I can't have a decimal. So it's not anything real numbers because that has decimals and fractions. So it has to be between whole numbers and integers. And because it has negative it doesn't have, this does not include negative numbers because negative doesn't make sense. It has to be positive numbers, which is going to be what? Whole numbers. So what are my options? Not that, non-negative real numbers, no, because it can't have decimals. Real numbers within, no, because it can't have real numbers. Integers, okay, no, because that has negatives. Whole numbers, 0, 1, 2, 3. So far, yes. Can I have a 0 though is the question. So this one didn't even ask if I can have a 0. So I'm going to check it real quick. Can I have 0? Does it make sense to have 0? So I'm going to put 0 right there. Oh, no, it does not make sense. So they didn't ask that, but I cannot have 0. So if I cannot have 0, all right, so let me go back to my answer choices. All right, so if I cannot have zeros, well, integers isn't it because of negative. Can I have 0 right here? No. So it's not that. Positive integers, can I have 1, 2, 3, 4, 5, 6, 7, 8? Yes, that's the number. Oh, sorry. That's the answer that I am looking for. Okay, so the only reason that it wasn't whole numbers is because of this 0. And since they didn't ask me to do that in the question, I went ahead and put 0 in the calculator so I can also check if it does make sense. All right. But look, this is one of those questions that you have to kind of get used to. Okay. So again, if you did not understand what I just did, please be sure that you go to the video. All right. Evaluate functions. So again, the video is underneath the date. Okay. Evaluate functions. So we're going to evaluate this function. All right. So I want to take a look at evaluate functions. Evaluating functions, all that means is you're evaluating this function at -4. You're plugging in -4 where you see x. Okay, so all you're going to do is copy down your function that they give you. So you can Control C, and hopefully this works so I don't have to type it. Control C is going to copy it, come over to the calculator, Control V, right? Everywhere you see X, because this used to be the X spot, but instead of X now, we have -4, right? So anywhere we see X, you have to put an open and close parentheses. Okay, so an open and close parentheses. And you can hit this keyboard in Desmos to find the parentheses right here, to find anything that you need really. All right, open and close parentheses. Now, instead of this X, you're going to put what? -4. So you put -4 in there, and boom, that's my answer. So G of -4 is -18. And you did evaluate in this functions when you did domain and range just now. That's it. All right. So no matter what it is, let me see if It won't let me do any more, right? No matter what the function is, copy it down, put parentheses where the x is, and then plug in the number they tell you to evaluate. So here's a different question. Control C, Control V. Where I see x, I'm going to replace that with parentheses. Okay, and then I'm just going to put in whatever the x value is. So they tell me x is equal to 4. I'm going to put in 4. And when you evaluate that, 4 times 4 is 16, minus 1 is 15. Writing equations of lines. Okay, so writing equations of line. All you need to know for writing equations of lines is what a linear function looks like. And this is on your formula sheet in case you forget, but you do need to know what it means though. So write an equation, it must look like y equals mx plus b. It has to look like this, where b is what? By now you're probably tired of hearing me say this. The y-intercept, and m is what? The slope. Once you know that, all it is you're finding what the y-intercept is. So what does that mean? Where it crosses the y-axis. So where does it cross the y-axis? Here's the y-axis. Where does this line cross this line? So I can look for my little crossing right here. So it crosses at 6. So the y-intercept is 6, positive 6. Okay. Now, because it says equation, the word equation, equation must have an equal sign. So an equation, you must write the whole thing. All right, the other piece of information that I need is the slope. Well, how do I find the slope? If you can't do rise over run, which we've talked about before, remember, you go into the formula sheet, you find slope, and then you do what? You put this in decimals, and you let it calculate it for you. What is the letter that goes on top? Y. The letter that goes on the bottom is X. And you put in the numbers, and it lets it calculate for you. I'm going to do it both ways in case you prefer one over the other. So I'm going to do rise over run. So I go from this point to the next point. It doesn't matter which side I go. It doesn't matter. I'm just going to go positive because it's easier. When I rise 1, so I rise 1, that's what? Plus what? 1. And then I'm going to run. So I rose 1, and I'm going to run 2. If I went to the right, it's positive, so that's positive 2. Then you simplify this. You put this in the calculator and let it simplify it for you. All right, once it simplifies it for you, it's 1/2 x plus 6, and I just wrote my equation. So basically, find your y-intercept, find your slope, put it in the equation. I am going to put this in decimals so I can show you how to do that. All right, so once again, in decimals, remember you want to put in decimals, you want to put the division first and then do the parentheses. So parentheses minus parentheses over parentheses minus parentheses. If you don't, it's going to look funky, and if it looks funky, just correct it. All right, now you just need 2 points, and remember on the top should be what? Y, on the bottom should be X. So any 2 points is going to be okay, whatever 2 points that you want. So let's say I pick this point right here, okay? I want the top to be y, so I'm going to go to the y value first. That's 11. When I come to the calculator, I'm going to put 11. What does 11 go with? It goes with 10. So on the bottom, on x, I'm going to put 10. Okay, I'm going to pick another random point. Let me pick the one that's over here. It doesn't matter where. So let me pick this one. I need y on the top, so I'm going to go to the y-axis first. What's that number? 2. So I put 2 on the top because it has to be y on the top and then x. All right, what does that point go with on the x direction? So I go to x, and what is that number? -8. So I go here, and I put -8. And we should get a half like we did before. Oh my gosh, it's a decimal. What do? You click this circle, and boom, you have the same 1/2 if you were doing rise and running. So whichever method is easier for you, please go ahead and choose that method. It does not matter. So you find your y-intercept, and you find your slope, and then you write your equation. So I write my equation because it's an equation, equal equation. It has to have the equal sign. So I go y equals my slope, which is 1, divide by 2 /2, or you can click right here. In fact, let me click right there and hit divide by 2, and then x. Now, if I put x now, is x supposed to be on the bottom like that? No. So just be careful with what you're typing. Click out of that, then x. And my y-intercept was 6, so plus 6. So now I'm just putting the information back in here. All right, and looks like there are 2 questions on the test because it says 1 out of 2. So 2 questions are going to be asked of this. So make sure you do enough practice on that. All right, I guess I need to finish it. I'm going to do this one just really quickly. So remember, it's y equals mx plus b. I'm just going to go ahead and write it in here so that I have how it's supposed to be written. And then I'm going to put in the information. So I start with my y-intercept. It crosses where? -3. So my plus b is -3. And then I go to my slope. I'm just going to do, again, you can do these 2 points. Actually, as a matter of fact, oh man, I didn't mean to do that. I am going to do these 2 points really quickly. All right, pick a point. 9 goes with 9. Okay, so 9 goes with 9. So y on the top, x on the bottom. Here's another one. -3 goes with -7. -3 goes with -7. So my m is 3 divided by 4. Why is the answer not correct? -3 crosses -3. 9 goes with, 9 goes with 9. And then what I do, oh, I put my x. Ooh, be careful. It's what? Y goes on top. Okay, so the y value, not the x. So -7. So be very, very careful with that. Goes with -3. All right, y on the top and then x. So it's 4/3. Okay, that's because I didn't write it down. So this is the importance of showing your work. Make sure you write it down. So write an equation given a linear situation. There's only a specific kind of question that I'm going to give to you. So I'm just going to make sure this is one of those. Yeah, this is not the question I'm going to give you. So that's fine. I'm just going to skip it. I'm going to show you just the question I'm going to give you. All right, question like this. This is one that I'll give you. All right, so I'm going to go over a couple of these just to make sure you understand it. I am going to choose the kind of question I'm going to give you. So this one is what it's going to look like. All right, and really what it is just, it's a linear equation in context. Okay, so it's y equals mx plus b in context, where b is your y-intercept, which is, again, your original or your initial or your start, all that it means the y-intercept. And then m is your slope, how it's changing, your rate of change, how something is changing. All right, so a baby is born with a weight of 5 pounds. So it's 5 pounds, your start or how it's changing. So if I say if a baby is born with a weight of 5 pounds, is that what I start with or is that how it's changing every whatever? Well, if you're not sure, you read the rest of the question. And began to gain 1.25. So now that you know your second sentence, which one does 5 mean? So the baby is born with a weight of 5 pounds. Starts, okay, so that's 5 pounds is my y-intercept. So a baby starts with 5 pounds and then begins to gain. Now, which kind of direction is gain? Positive, right? So it's going to be plus 1.25 per month. So per month, every month, the baby is gaining 1.25. So if you write that down, your slope, how you change it, it's your gain, which is 1.25. And be careful because sometimes this could be negative. Because it's gain, it's positive. So 1.25 per month, so x is in terms of months, plus your y-intercept, which is 5. And again, I'm going to do a couple of these problems just to make sure that you understand. So that's how you write your linear equation. All right, let me do another one just to make sure we're on the same page. Oh, and please be mindful, I did forget to say, watch what the variables are. So don't use y and x, use whatever they tell you in the question. So you'll see 1.25 plus 5. It's supposed to be t and w because I forgot to look. They told you what it was in the question. So write an equation for w in terms of t. Okay, so I'll be mindful of that when I do this next problem. Let me see if this is one that you'll do. Yes, this is another question, kind of like what you're going to be getting. So I'll go ahead and go over this one too. All right, so Aliyah salesperson. So again, remember you're doing y equals mx plus b. And you just need to find where's my initial, how is it changing? That's all you need. So find your first number. She makes a base pay of 70. What's that? How it's changing or what it is? It is what it is. So that's plus 70 because it's $7 is positive. All right, how is it changing? It's changing at 1.25 commission per for every computer she makes. So 1.25, is that positive or negative? It's positive because she makes the 1.25. She doesn't pay 1.25, so it's positive. And then remember, in my previous question, I kept y and x, but you have to use whatever letters they give you. So write an equation for P in terms of x. So this should be capital P equals 1.25, the one x in the question, x plus 70. All right, so please make sure you use the variables that they're using in the questions. But that's all. All right, so we're going to take a look at graphing lines from equations. Graphing lines is pretty straightforward. Again, everything is y equals mx plus b, where b is the y-intercept. So you go to 4. That's the y-intercept. Then this tells you rise over run, right? And you can put the negative on the top or on the bottom, doesn't matter. So I'm going to put it on the top. -2 in the y direction means I'm either going to go up or 2. Because it's negative, I go down. And then right 3, 1, 2, 3, because in the x directions, remember it's always y and then x, right? So y first and then x, and that's it. But again, you can just do what? You can copy, Control C, and you can Control V. All right, it looks funky, so kind of fix it. So I'm just going to do Control X, bring it up here. X out of all of these and just fix whatever that should be. So it should be the fraction is what's missing, and just make sure that you copied exactly what it is. So that's what I think my graph should look like, which is right. Look. All right, so hold on, make sure it goes up. I'm scrolling in like this to make sure it goes up by 1, and then I'm going to make this a bit on this side and put this where you can see it, get rid of that. So I want you just to be able to see this real quick. All right, so you can see it goes over 4, it goes down, and I have a point here at 3, 2, right? So I'm going to see, do I have a point at 3, 2? I do. So I've graphed it correctly. Now, if you are going to get it from Desmos and transfer it over, you just need to find 2 corners. So this is a corner, put it in. Then come find another corner. This is another corner. So the 3, 2 that I found was a corner. So put that in, but let's say you didn't see that one. Find another corner. Here's another one at 6, 0. So look, 6, 0, put that in. So just find 2 corners and then you're going to put it in. So if you're using the graphing calculator, that's what you're going to do. But if you're doing it by hand, how I did it is fine. All right, so let's submit our answer. Okay, I'm going to do one more just to make sure we're okay, because it says there are 2 questions on the test. Again, all right, you start at your y-intercept. So where do I start? At 3. And then there's invisible. There's nothing here. So what does that mean? I need to have a fraction. So when you have an invisible like this, you can say invisible 1 over invisible 1. So remember, rise over run. So you go up 1, right 1. All right, again, I'm going to take this and Control C, and I'm going to check it with my calculator. All right, now remember, I just said invisible 1. So you don't have to type this in, but I'm putting this in to show you that it's the same thing no matter what. So where is this graph? Again, zoom out here, zoom out so you can see it. Zoom in so it goes up by 1s. You know, however you need to kind of see. So here's the graph right here. And I'm going to show you that it's going to be the exact same graph without this 1 over 1, because the 1 over 1 does not change anything. So you see the red line and the black line are the exact same thing. So the only reason I write this 1 over 1 is because I want to tell myself to rise 1, run 1. But if you're using the calculator, it's just right there. Find what? 2 corners. So here's a corner. Here's another corner right here. It's a -1, 2. If that doesn't work for you, here's another one. -2, 1. So now I'm just going to go back to my question, make sure -2, 1. Yep, that's on the right. -2, 1 was a corner. And 3, 0, 0, 3, I'm sorry, was another corner. So that's how you transfer it. So you can do it forwards or you can do it backwards, whichever way is easiest for you. All right. All right, then we're going to take a look at standard slope to slope intercept form. All right, so standard slope to slope intercept form. I'm going to actually just show it to you on the graphing calculator, and really I'm going to use the graphing calculator to make sure I'm right. So I'm going to show you my work here, but remember, if you're going to do it this way and show your work on Desmos, you have to write down what you're doing. So here's my question, right? Okay, so I'm going to show you this. Keep an eye on this graph. So it's purple. I'm going to take this question. I'm going to, oh, sorry, not do that. I'm going to take the question, I'm going to go Control C, Control Paste, because I'm about to do this work. So solve it to make it y equals. First thing I need to do is get rid of this, right? So I'm going to get rid of this. I'm going to take it to the other side. So if I take 3x to the other side, it's going to become what? Negative 3x. All right, so I'm going to put negative 3x here. But remember, and you see, look at that. I'm still okay. I did it right because those are they're still the same lines. I need negative 3x to be first because I need it in mx plus b. So I'm just going to Control X, Control V. So I'm just showing my work in Desmos here so you can keep checking if your work is right every step of the way. All right, to get y by itself, I have to divide everything by what? Negative 2. So I'm going to copy the line again, Control C, paste it, Control V. I'm going to divide everything by negative 2. That means I come here, I hit divide by negative 2. I come here, I hit divide. Now look at my lines. You see my line is over here. It's off, right? Because I'm not done yet. I need to divide by negative 2. Boom. So far, see all my lines are the same, which means my work is the same. Now I come in, I need to write down my final answer because you can't submit this to me. That's not simplified, right? And you can do this part in the calculator just to make sure you're okay. So now I'm on green line. All right, so negative 3 divided by negative 2 will give me 1.5. And how do I make that a fraction? It's 3 over 2. So I'm going to erase this. I'm going to erase, see how it changed, green line? But it's going to change to blue. Boom. All right, now simplify this part. So this one is negative 2 divided by 2. No, negative 2. All right, so it's supposed to give me 1. So this right here is going to give me what kind of 1, though? Positive. So right now it's wrong because I haven't put it in yet. Plus 1. And now we're back on that line. So here's my final answer. And here's the work showing how I did this question. Making sure that all these lines are exactly the same. If they're the same, I know I did it correctly. So if you're using it, if you're putting it in Desmos, please remember to write down what you put in Desmos. So you'll write these 4 lines down. Control C to copy, Control V to paste. Make sure it matches. Yes, it does. Submit your answer. I don't know why it's not submitting, but okay. Maybe it doesn't like that I pasted, so let me do something else. Let me type it in. Y equals 3 divided by 2. I think it was 3 divided by 2x plus 1. Oh, okay. It just took a second to load. All right, so again, you can use the Desmos calculator for your work to check every step, but just make sure you write it down on the paper. All right, so we are on graphing by intercepts. All right, intercepts. You know, for intercepts, you copy the question down how many times? 2 times. So I'm going to do my work on Desmos just so I can show you. So you copy the question 2 times, right? Then you block 1. So it doesn't matter which one you block. So let me block, in the first one, let me block the x. So x is no longer there. Okay. Now I solve this equation. So how do I solve that? How do I add? I'm going to take this out for a second. How do I solve this? I divide both sides by what? Negative 10, right? So it's going to be y equals 20 divided by negative 10. So 20 divided by negative 10. Negative 2. So my y value is negative 2. My y value is negative 2. And be careful to drag it as close as you can. I'm going to repeat the same thing this time for x. So here's the question twice. This time I took out 10y. Now I'm going to take out, I took out y before. Now I'm going to take out, I took out x before. Now I'm going to take out y. So I take out y, cross that out, and I solve this equation. 5x equals 20. You divide both sides by 5. So that's going to be 20 divided by 5. So it's going to be 4. X is equal to 4. So x right here is equal to 4. All right, to check that, of course, I'm going to check it. Control C. Paste it. Control V. Now I need to see if my line looks like this one, right? Zoom out. There's my line. Find my y-intercept is at 40. Is my y-intercept at 40? My x-intercept. And then my y-intercept is a 0, negative 2. Yep. So those lines do match. Okay, find 2 corners again. All right. Those lines do match. So that one is my answer. All right, comparing features. Okay, so we did this in class, comparing features. It has to be x-intercept, y-intercept, or slope. But anytime you see slope, you should automatically in the calculator start by putting divide, not that, divide. And you want to say parentheses minus parentheses over parentheses minus parentheses. And I get that straight from the formula. Okay, so I have that ready to go no matter what. All right, so find the slope from an equation. If it's an equation, you control C, copy it into here, control V. Now you can do it a different way. It's a little bit longer, but I'm not going to show you that way. We've done it already. I'm just going to show you how to quickly get it. So, because I know you can do it from a graph. So by putting the equation into here, I've made my question a graph. So now I'm just going to do it from the graph. So watch this. Make it go up by ones. Okay, so I'm just zooming in to make it go up by ones. Then I'm finding my equation. I need to find two corners. Okay, here's a corner right here. All right, remember what goes on top? Y. So 0 goes on top, -2 on the bottom. So 0 and -2 on the bottom. And then you're going to find another corner. So I'm just going up looking for a corner. Here's another corner right here. It's pretty close. There you go. There's my corner. What is it? -1, 3, right? What goes on the top? Y. So what's my Y? 3 on the top, then -1 on the bottom. So 3 on the top, then -1 on the bottom. Once you find your corners, you find your slope. So that's my slope. So my slope is +3. So +3. My slope for line A is +3. And for B, here's the equation. So here's the graph. So again, find any two corners, right? Any two corners. So I'm going to come here and erase these points. Any two corners. So what is a corner? Let's see right here. What's my Y value? Y on top first. 4. And it goes with -9. So 4 goes with -9. And then another corner right here. 2 goes with -6. 2 goes with -6. Oh my gosh, that's so weird. Okay, so what do I do when I get a weird looking fraction? You click this and it makes it a fraction. So it's -2/3 is my slope. All right, so the slope of line A is 3. The slope of line B is -2/3. Therefore, slope of line A is greater than the slope of line B. Okay, so the first question they can give you is slope, and then the rest is the x and the y-intercepts. And all you have to do for those is just look at it, right? Now, if you did get slope from a table, again, your points just come straight off the table. So this one, x-intercept, we're just going to copy, Control-C. Then we're going to paste, Control-V. To cut, Control-X, paste, Control-V. All right, we're going to look at the graph, and we're looking for what? Where it crosses the x-axis. So let's take a look at where it crosses the x-axis. Crosses right here. What's that point? At 4. When x equals 4 is where it crosses the x-axis. So it crosses at 4. Where does it cross the x-axis? Here. So it crosses the x-axis right here at 1. Therefore, the x-axis, line A is 4, is greater than 1. And if the question was y-axis, then you would look at the y-axis. All right, last question, graph in linear inequalities. So we already did this in class, but of course, you can just check this by transferring points. Copy, Control-C, paste, Control-V, cross out everything else. So I need to find two corners so I can put it in my equation. So let's find the graph first. So I'm zooming out, just zooming out, zooming out, zooming out, zooming out, zooming out. Where's the graph? Oh, there's an error. Sorry, I don't understand. Okay, so I guess the symbol is wrong. Okay, so I guess when you copy it, I guess it's a different symbol. Just delete it and put it on. Now I see a graph. All right, zoom in so that you can get between 10, because you need it to be in 10, right? -10 and -10. So zoom in till it's going up by ones. There we go. And find me two corners. So let's look. There's a corner right here, right? And if you can't move it exactly, you can just look at it. It's -4 and +1. So 1, -4. That's a corner. All right, let me find a different one. So boom, 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 boom. Right here is a corner right here. And again, if you can't get it exact, you can just, look at it. So this is 2, -1, 2, -1, 2, -1. So I'm gonna zoom out just to make sure the graph looks like that. Yeah, it looks like that. All right, now notice it is a dotted line because there's no equal sign, so change it. And then it's small, so the small numbers for y are down here, so you just change the shade because it needs to look like what you have. And that's it. That's your whole study guide.